It's my pleasure to present a little overview of Quantum Opus. We're a global supplier of superconducting nanowire single photon detectors, so very, very high performance single photon detectors and systems. It's a technology that has really been born on about 30 years of work, all the way from my graduate work at Stanford back into NIST, and then more recently in these kind of higher temperature superconductors that have really taken over the quantum world as the gold standard for photon detection. We're based in Plymouth, Michigan, near University of Michigan and Detroit, which is very convenient for our manufacturing. I wanted to give you a little insight. It's kind of interesting to look at what happened to Quantum Opus's revenue in the last 8 years. It gives you a little view of who our customers are. Most of our customers early on were researchers, half of them in the academic sphere. So we work very closely with innovative researchers and respond nicely to partnerships with people who are really working at the forefront of quantum technologies in particular that require extremely high performance photon detectors. The other major part of our revenue was coming from government researchers, so FFRDCs in many ways, and government applications. And there it's been extremely valuable for us to have complete control over the manufacture of our systems, all the way from silicon, where we manufacture the devices from the ground up, design, manufacture those, install, test them, build our own systems, and ship very reliable and compact units for people who have demanding specs. But very recently then, we've seen almost a quarter or over a quarter of our revenue in the last 2 years coming from where this community is kind of playing in this in the industrial area, which has been exciting because that's caused us to have to be a little more agile in what we do. So reducing our lead times and also just cycling very quickly with researchers and manufacturers in an industrial sector means that we're actually putting product into products rather than just into research labs. So it causes us to think about the specifications and the engineering of the systems much more heavily. So that's been pretty exciting. But in all of these, we partner very, very closely with our customers. What we offer are, as I said, kind of soup to nuts photon detectors, superconducting photon detectors that are nearly perfect. We can talk more about those if you're interested. We package them into compact and robust cryogenic systems that can either be desktop mounted or rollable, move around, wall plug and need nothing else, self-contained in all ways, 24-hour operation, hands-free operation, network controllable, so very convenient usage. But then we also push the performance of these devices and these systems very, very hard. So we can do billions of counts per second at 98% efficiencies and extremely good timing performance, 15 picoseconds, things like this. So we're always excited when a customer application demands something we can't do, because we can usually work really hard to try to meet those. And that's way that we can work with you on your ideas all the way out to the implementation, which includes, in our part, a partnership with our customers after sale in software development or operation, training, installation, all these things that we're excited to do, because at the core, we're scientists and we really like spurring science by better tools. So that's what we end up doing. Most of our customers, especially early on, were in the quantum industry, as I mentioned. So we have customers in quantum networking, information science, quantum computation, photonic quantum computation. Also, people who are integrating novel sources that require very good detectors. So that's a very good pairing commercially. We also have worked really hard on our sensing and metrology, and how do we know that what we're providing is what we're claiming we're providing? It's very difficult at the single photon level. So my background in NIST has really pushed us to try to understand our specs extremely well and be able to measure those at the single photon level. So we have a lot of expertise in that area. And we're starting to dabble now into more scalable technologies, integration of superconducting systems into other people's photonic processes. So those collaborations are coming in this commercial endeavor as well. It's also exciting that we have applications outside of quantum, free space communication, MarsCom with NASA, or in the medical technologies. These also benefit. They also help the quantum industry, because higher volume here just means everything gets better for everybody. So that's pretty exciting. We've been super thankful for the beneficial connections within QED-C and the CQE that we were a part of, the Chicago Quantum Exchange early on, that has really merged together government research, academic research, and in industrial research, but also is spurring these industrial connections that we have that really we see as being the growth in the future. So how can you help, and how can we get what we need out of this? It always helps us to know what the industry needs are. If we don't know the need is there, it's hard for us to innovate and meet those. So we're really trying to touch base with everybody that we know to say, what's the driving need that we see 2 years in advance, so we can help meet that. And second, we're always looking for partners, whether that's just partners in your commercial application, or if there's really a dominant growth path that we see, we're going to have to partner with people who can help us scale. So we're always looking for that sort of either co-investment or cooperation in terms of how we're going to meet those scaling opportunities as they come. This industry is scaling rapidly, and so we're not going to be able to do that alone as a small company. So more information, feel free to check out our website, Quantum Opus. There's our LinkedIn thing there. Appreciate your interest.